Okay, so we are continuing with 3.3 rotating on a grid. My last video was cut a little short. I just didn't have enough time, so I'm going to try to keep this one short so we don't spend too much time on this. So rotating on a grid, coordinate rules for rotation. Okay. On the next page, I created 3.3 rotating on a grid. This should be the same page number, just a different letter. We're continuing on the same day as of notes. Okay. So it says, what are the coordinate rules that describe motion of points? Okay, motion of points on a grid under the turns of 90 degrees and 180 degrees. So, and this is all around the origin. Okay, so I have my points ready to go down here, so I can label them. Let's start rotating. I'm gonna outline this flag, and then I'll rotate it, and we can see what happens. Again, this is in your lab sheet manual that you guys got and should have for 3.3. Okay, so a couple key things. It says counterclockwise, so I'm going to turn this item counterclockwise. Now I can't set my origin in this product that I'm using for the computer, but I'm going to rotate it 90 degrees. So what you notice is this line, this dotted blue line is up. I'm going to make sure it ends up vertical on this side. So, and it kind of snaps into place. There you go. The only thing is make sure is that A point ends back at A. There we go. So that's my 90-degree rotation around the origin. Here's my A image in the exact same spot. B is in the corner of this flag. C goes there. D goes there. E there. And I don't have an F, so I can delete that one. Okay, so we're going to start labeling all our points. A, B, C, D, E, and its image. Okay, so here are my points labeled, the images of each one. Again, we ran into this problem with reflections. The A point and the D point, they have the same numbers, so it's difficult to identify any patterns there. So what I'm going to do is I'm going to use all my other points and see what we get. So it looks like all of my points kind of switch. I have a 4, and that used to be a Y, now it's an X. My X's become Y's, etc. Here it remains the same. They switch places. It holds true for A and D also. It's just harder to recognize. 3 used to be an X, now it's a Y. Okay, so we can really briefly say that we had X comma Y. Oops, let's fix that. We had X comma Y, and now we have our rule says we have Y comma X. They switch places. Now that's not the only thing that happens. After they switch places, the 5 here stays the same. The 2 that used to be an X stays the same. It's a positive. 5 is a positive, stays a positive. The 6 stays a positive. The 3 stays a positive. The ones that are changing are all the Y's. All the Y's now have this negative in front. A negative there, a negative there. They have now become, they went from positive to negative. So we have to change that in our rule too. So not only did they switch places, but also the Y's now became our X's. So this is our rule for question A when we rotate 90 degrees clockwise. So a 90 degree, counterclockwise rotation, and there's your rule. Okay, that's what it is. All right, now we're going to do this one more time for question B, and B is the same thing except for they want you to do 180 degree rotation. Now, the interesting thing about this is the way they word it. They said rotate another 90 degrees, so they're assuming your point's already here. You're going to rotate it again. Okay, so let's go ahead and do that. Again, here's my flag with that 90 degree initial rotation. I'm going to do another 90 degrees. So it's a total of 180. I'll make sure my points line up. Okay. Okay, so here's our rotation for 180 degrees, and what you'll notice is it looks like almost the same thing, but just in the different place. So when I look at my numbers, they end up being all the same: 2 4, 5 4, 5 4, 6 6, 6 6, 3 6, 3 6. Again, the difference is in the signs. That's a negative, 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 negative. So we can say that our xy coordinates were x comma y. So they started off as x comma y, and they turned into the opposites, negative x comma negative y. So that's our rule for a 180-degree rotation. Again, we're only doing rotations around the origin. So rule for 180-degree rotation around origin is as follows. X comma y is x, negative x comma negative y. Okay, so again, at the end, make sure you write a summary. What types of transformations do we cover, and why are they important? If you translate a figure, how are the x and the y rules different for each translation? When rotating, what are the rules for 90 and 180-degree counterclockwise rotations? Okay, so just determining what the rules are, kind of talking about them again. In your own words and why they can or cannot be useful. Why do you think we even picked those rotations other than it was in the book? So questions, again, write a question you might have that you want to know the answer to. Write a question you think that someone else would have if you seem to know everything in here, which is quite possible. It's a fairly easy topic. If you rotated 90 degrees clockwise, not counterclockwise, make a prediction what the rule will be. And maybe write it in there so that way in case you see a 90-degree rotation, you know how to find it. Okay. We will work again. We'll also have some practice in class, and we might even do a little bit of notes in class so we could just move it a little faster since the section was so easy.